Hello and welcome back. Today we are going to talk about something that often confuses people when they first see it, the translation modifier. Now, the translation modifier is one of those clever tools that gives us a little bit of flexibility during inspection or assembly. What it really does is tell us that the basic location of a datum true geometric counterpart is not locked in place. In other words, instead of being completely fixed, the datum simulator, that's the surface or pin we use to represent the datum during inspection, is allowed to move or slide slightly within the specified tolerance zone. We call that movement translation. So what does that mean in practice? It means that the datum simulator can shift just enough to fully engage with the feature we're inspecting, helping ensure the part actually fits together properly in real life, not just on paper. Let's break it down with an example. Imagine we have a part that looks like this. And on the drawing here we have three datums. Datum A, that's a flat plane, the bottom surface of a part. Datum B, the upper 6.5mm hole. And datum C, the lower 6.5mm hole. Now there are 5 additional holes on the same part that need to align correctly when we assemble it. The 9.2mm hole, and the 4 small 5.1mm holes, as we can see on the drawing. These holes are controlled with a positional tolerance, and in the feature control frame, the datum C is followed by something you might see as a triangular arrow head, that little symbol after C. That's the translation modifier. Here's what it's telling us. When we inspect this part, the simulator for datum C, that is, the pin representing C, is allowed to translate move slightly to get proper alignment with the 5 holes being inspected. In this setup, the primary datum A, the flat surface, and the secondary datum B, the first pin, stay fixed. They don't move. But datum C is allowed a limited amount of movement, or translation, to help everything line up correctly. Now, sometimes it's not obvious in which direction that translation is allowed. Is it along X, Y, or Z? In that case, a coordinates indication can be added to specify exactly where translation is permitted. For instance, you might see something like X1, Y0, Z0. That means datum C's simulator is allowed to translate 1mm along the x-axis only, and not in any other direction. And now come the question, why would we need a modifier like that? Because in the real world, parts don't always assemble under perfect fixed conditions. There might be small shifts needed so that pins, holes, or fasteners can all engage properly without causing stress or misalignment. So the translation modifier helps us model that real-world behaviour by giving the inspection setup some controlled movement, enough to ensure proper fit and function, while still staying within the specified geometric tolerance. So to sum it up, the translation modifier is used when you want a datum simulator to be able to slide or shift slightly during inspection. It always appears after a datum reference in the feature control frame, and if the direction or limit of movement isn't obvious, it can be clarified using coordinate translation values, for example, allowing 1mm along X and 0 along the other axes. That's the beauty of this modifier. It gives you precision and practicality at the same time. That's it for this lecture. In the next lecture, we are going to talk about the projected tolerance zone. See you in the next lecture.